Hello, today we're going to present the paper A Unified Open Source IoT Web Platform for the Fred Factory project. The team is composed of me, Juan Pablo de la Cruz Rangel, Kaliani Villallicodat, Rodrigo Villalobos, Marcelo Peña, and Gabriela Peña Zúñiga. So, for context, Fred Factory is an Industry 4.0 and 5.0 development project. So, we're going to assess how to eliminate or at least reduce the economical and knowledge barriers presented in the generalization of Industry 5.0 and 4.0 technologies within small teams, small companies, and researchers' teams. So far, Industry 4.0 integrates some cyber physical systems such as cloud and IoT. It also integrates large scale facilities with which need significant investments. And we also have the concept of learning factories, which are like simulated environments for people to learn how manufacturing works. And within learning factories, we have the Fred Factory project, which comes from the fiber extraction device, alias FRED, which is a collaboration between the Tec de Monterrey and MIT schools, so that we can have a more accessible learning factory for people. So it is about generalization, and in this team, we introduce some industrial tools such as SCADA and MES. Manufacturing frameworks, but they are costly and mostly complex. So we are trying to replicate the benefits of these platforms within organization and organization within the manufacturing without the cost and knowledge requirements. So far, for the Fred Factory project, we have identified some key people groups that can be benefit from a unified, centralized platform, so that we can centralize IoT tools in a non-costly or complex manner. So we first have three main groups, which are the members of the Fred Factory project, which will be more efficient and will work more comfortable. We then have the leaders, which are part of that member groups, and they can benefit from those advantages, but also with monitoring tools that can track performance of groups, teams, individuals. And we then have externals that do not have anything directly to do with the team, but can get to know what is Fred Factory doing, so that we can get like better stakeholders. Now, we also identify some six requirements for the Fred Factory project in this specific case, which are: first, we need authentication. Why? Because we have to know who is who within the page, so we can assign tasks or tools. We also have to identify them in order to classify them as member, leader, or external. We also need role-based access, which is just what I just explained. We have to know the classification of each user of the page. And we require also member management, which is no more than the users having the capability to modify the profile information, so that they can update, for example, the themes they are participating in, or I mean, contact information, anything like this. And then we have the services required for the Fred Factory project currently, which are: we first need a shared calendar so that we can have a better organization. We also need inventory tracking, so that people within the teams can know if there is material that they need to buy, or if they have it, so they do not have to buy it. And the 3D printing telemetry, because we used to print a lot, so we usually have like very complex queues on the printers. So centralizing it in the web page can allow people to be more efficient.
The system architecture is divided in four different layers. The first one is the presentation layer. This is the first thing you see when you log into the page. It is everything visual that was created so that the user may have a certain experience within the page. We built it using HTML, CSS, and JavaScript. We chose a web app over a downloadable one because we saw that it was easier for the members to access, and also it was smoother with the real-time data and the external tools. Next is the logic layer. You can think of it as the brain behind the scenes. We used a Python and Flask backend so it could handle all the routing, manage user logins, and also move data seamlessly between the external tools, the servers, and the database. After that, there is the data layer, on which we used Supabase that is built on PostgreSQL. This is where all the user info and permissions are securely stored and organized. And finally, we have the physical devices layer, on which all the external hardware tools are connected so our members can use it within the page. And this was done by setting custom servers and also developer APIs.
Now, the six modules corresponding to each requirement can be seen here in the current slide. We first have a login, sign up events in the platform so that they can have the roles based management, the authentication, and that stuff. Then we have the shared calendar. Then we have the IoT, the tracking inventory through IoT, and we finally have the 3D printing queue for the 3D printers. Then, regarding how we are going to measure the if the web page is functional and more than functionality, also in which manner is it working, we have a delay time experiment so we can identify if we can have real time management of the information in the web page, because that would allow us to have uh, also a better organization but a better tracking of what is happening in the lab. And thus, if it is working in that way, we can then implement more complex projects in within the page. So we run some experiments. We run training tests on the page, modifying the data inside the database so that we can measure how much time does it take to modify the data in the user's dashboard, and we found that we have an average of 604 milliseconds, which is within a second, which is pretty good for our current necessities because we do not need like real closed loop controls from the web page. So it is reasonable, and we can work with that. Now, regarding open source and free access, we implemented only those types of services or tools in our webpage so we can have a very democratized platform, which includes Python programming languages, JavaScript, HTML, which is very standardized for most browsers. We also used Supabase as main database, and we were hosting in Render, which is a server uh, provider, which is free, so that we can generalize the most our platform. And we in this way we can have similar functionalities as in Tulip, but without paying anything or little, so that we can have a better generalization. And well, we found that we have some limitations such as latency, because even though it works for now, if we have want to have like closed loop or like real time monitoring, we're going to have some delay, like half second. Also, we're currently just using Bumble app APIs because we only have Bumble apps. But if you want to add another 3D printer brand, you have to first see if they have an API or not, and then like implement it. And those are the limitations. Talking about the implications, it replicates what Tulip is currently doing, but in a lower cost. The latency can coordinate people, but uh, as I just said, it can represent a limitation for closed loop controls. And role based access and management allow us well to have a better management of what is happening in our web page. So, in summary, We developed and implemented a centralized open source IoT platform for the Freight Factory project so that we can centralize all our tools so that we can have a better management of people, tracking performance, tracking of inventory, uh, and also to experiment on how we can implement these Industry 4.0 and 5.0 technologies within teams, small teams, or that do not have a lot of budget so that we can have a better generalization of current technology. Here we have some of our references which you can refer to in the document. And that is pretty much it for today. Thank you so much for your attention.